Good morning, students. In the last lecture, we discussed about the formation of stationary waves and we also get the equation of the stationary wave. We are going to revise the equation of stationary wave. Suppose there are two waves, y1 is equal to a sine 2 pi nt minus x by lambda. This is a equation of a progressive wave which is traveling in a positive direction of x-axis, and similarly y2 is equal to a sine 2 pi nt plus x by lambda. Okay, this is the second equation of the progressive wave which is traveling in a negative direction of the x-axis. Here, these two waves are similar in some manners. Both the waves have same amplitude and same frequency. It also same wavelength. They, when two types of waves combine with each other, superimpose on each other, then they form a new type of wave which is called as a stationary wave. So, by analytical method, we derive the relation for the stationary wave. Suppose y is the total displacement, then we write here is a sine 2 pi and t. This is the equation of the stationary wave. Now, this equation does not contain the term containing x, that is the displacement. Therefore, we can say that the wave is localized in a particular area, or it is vibrating in a particular region. So, such type of wave is called as a stationary wave. Okay, so what is the condition to form the stationary wave? The main condition for the formation of stationary wave, the two waves must be identical amplitude, same frequency, same wavelength, traveling along the same path but in the opposite direction. They form a new type of wave which is called as a stationary wave, and by analytical treatment we derive a relation y is equal to a sine 2 pi and t. This is the equation for the stationary wave. Why it is called stationary wave? Because this equation does not contain a term of x, that is the displacement. Now, in this equation, what is this a? This a is the amplitude of the stationary wave. This capital A is nothing but the amplitude of the stationary wave, which is given as this amplitude is equal to twice A cos 2 pi x divided by lambda. This is the amplitude of the stationary wave, which is depend upon. On which factor it is depend upon? It is depend upon the displacement. Means, as the displacement of the particle changes, the amplitude of the stationary wave also get changes. So this amplitude is a periodic function. Why periodic? Because sine and cos, they are the periodic functions, and here cosine of this angle means this amplitude is the periodic function of the displacement. Okay, therefore this amplitude is depend upon this displacement. Now, today we are going to simplify, or we are going to derive a relation for node and antinode. Node and antinode. Node are the point in the stationary wave which vibrate with the minimum amplitude, and antinode are the points which can vibrate with the maximum amplitude. We are going to derive the conditions for the formation of node and antinode in a stationary wave. How stationary wave physically represented? It can be represented like this. Look at here. Here, this point, they vibrate with a minimum amplitude, and such points are called as a node. They are denoted by capital N. And these points, this point may vibrate with the maximum amplitude. Such type of particles are known as, such type of region are known as antinode. Again, this is a node, this is antinode, this is node, and this is antinode. This is node. So, what is the condition? The condition is that the node and antinode are alternately formed, and when the string is connected to the rigid support, then at the rigid support always there is a formation of a node. Okay, so now we are going to derive a property, derive the condition for the formation of node and antinode. Where this node and antinode form, we are going to derive it. Okay, so first we are taking about the condition for node. When the nodes form, the nodes are formed when the amplitude of the particle is minimum or it is equal to 0. The particle doesn't vibrate, they remain at their position, original position. So we can say that for node, what is the amplitude? The amplitude for node is equal to 0 because they doesn't vibrate about their mean position. So A is equal to 0. Now, what is A? Is the resultant of the stationary wave, but we derive a relation for the amplitude. What is A is equal to? This is equal to twice A cos 2 pi x divided by lambda, which is equal to 0. Simple relation. Okay. Now, this term is the product of, this term on the left hand side is the product of twice A and cos 2 pi x upon lambda. Now, what is A? A is the amplitude of the original wave. This small a is the amplitude of the individual wave, which can't be 0. Okay, so therefore we can say that this term is not equal to 0 and the product of these two terms is equal to 0. It means that this twice a is not equal to 0. Therefore, what is 0? This term is equal to 0. So we can write here this cos 2 pi x upon lambda is equal to 0. Okay, now this is the angle. So cosine of what angle? Cosine of what angle is equal to 0? We know that cos 0 is equal to 1 and cos pi by 2 is equal to 0. So we can say that this 2 pi x upon lambda must be equal to 2 pi x upon lambda. It must be equal to pi by, what pi by? It is pi by 2, 3 pi by 2, 5 pi by 2, like this. Okay, if we keep this pi by 2 here, then it is equal to 0. If we keep 3 pi by 2 here, it is also equal to 0. If we keep this 5 pi by 2 here, it is also equal to 0. So, therefore, the value of 2 pi x upon lambda may be pi by 2, it may be 3 pi by 2, it may be 7 pi by 2 or any other value like 7 pi by 2, 9 pi by 2, like that. So, first of all we take this 2 pi x upon lambda is equal to pi by 2. Okay, so what happens? This pi and this pi on the either side of the equal sign get cancelled. Therefore, we can write this x is equal to, this lambda goes here, this lambda, and 2 goes here, this is equal to lambda by 4. So, x is equal to lambda by 4. What does it mean? It means that the particle at a distance x is equal to lambda by 4, there is a formation of node. Okay, so if there is a formation of node at lambda by 4, then where is the another next node is situated? So we can calculate the another node by keeping 2 pi x upon lambda is equal to 3 pi by 2. Okay, again this pi and pi get cancel and this x is equal to 3 lambda by 4. Okay, like that the next will be formed at 5 lambda by 4. In this way, where is the node are get formed? This node are get formed when this x is equal to lambda by 4, another is formed at 3 lambda by 4, another is formed at 5 lambda by 4. So, if we need to find the distance between two nodes, okay, so first node is formed at lambda by 4 and the another node is formed at 3 lambda by 4, then what is the difference, what is the distance between the two nodes formed? So how we can calculate? So we can calculate it like this 3 lambda by 4 minus lambda by 4 is this is the distance between two successive nodes, which is equal to, now this is the common 4, we can write here 3 lambda minus 1 lambda, it is equal to 2 lambda, and what is this equal to? It is equal to lambda by 2. So the distance between two successive nodes is equal to lambda by 2. After lambda by 2 there is a formation of node. Okay, so we can say that the distance between the two successive nodes is equal to lambda by 2. If we subtract this 3 lambda by 4 minus 5 lambda by 4, again the value must be lambda by 2. So every time it should be noted that the distance between the two successive nodes is equal to lambda by 2, where this lambda is the wavelength of the wave. Okay, so this is the condition for nodes. So we can derive a simple relation for this. If we observe here, this x is equal to lambda by 4, this x is equal to 3 lambda by 4, x is equal to 5 lambda by 4. If we observe carefully, it is concluded that it is the odd multiple of lambda by 2. Okay, so we can write here where the nodes are formed. The nodes are formed at odd multiple of lambda by 4. What is twice p minus 1 indicate? This twice p minus 1 indicate the odd integral. And this p is varying from 1 to 3 up to infinity. So if we keep p is equal to 1 here, so it is equal to 2 multiplied by 1, which is equal to 2, minus 1 is come to be 1, and 1 multiplied by lambda by 4 is equal to lambda by 4. So the first node will be formed at lambda by 4. Okay, then what is another? If we keep 2 multiplied by 2 is equal to 4 minus 1 is equal to 3, so it is equal to 3 lambda by 4. So in this way, where the nodes are formed? The nodes are formed when they are the integral or the odd integral multiple of the lambda by 4. Okay, and what is the distance between two successive nodes? The distance between two successive nodes is equal to lambda by 2. Now we are going to discuss the condition for antinode. Okay, this is the condition for node, and we are going to see here the condition for the formation of antinodes. So what is the formation of antinode? Antinode are the points at which the particles can vibrate with the maximum amplitude, and the maximum amplitude the stationary wave can get is equal to plus minus twice a. What is plus minus twice a? Plus twice a means it can vibrate in the upward direction, and minus twice a is, it means in the downward direction. Okay, so it may take the value from plus twice a to minus twice a. So we can write here for the antinode, the amplitude A is equal to plus minus twice a. Plus minus twice a, where this a is the amplitude of the individual wave from which the stationary wave is forming. Okay, so a is equal to plus minus twice a. What is a is equal to? This a is equal to twice a cos 2 pi x upon lambda, which is equal to plus minus twice a. Now here this twice a and this twice a get cancelled. So we can write here this cos 2 pi x upon lambda is equal to plus minus 1. Okay. Now cosine of what angle is equal to plus 1 or minus 1? So we can write here. So this angle 2 pi x upon lambda must be equal to, either it is equal to 0, it is equal to pi, it is equal to 2 pi, like that. If we keep 2 pi x upon lambda is equal to 0 in this equation, it comes out to be plus 1. If we keep pi in this equation, it comes out to be minus 1. If we keep 2 pi, it is again equal to plus 1. So, if we keep these values of the angle, we get the values plus 1 and minus 1. So, like this, we are going to derive the first condition or the first position where the antinode can be formed. So, we can write here this 2 pi x upon lambda is equal to 0. Is equal to 0. Therefore, we can write here this x is also equal to 0. So, x equal to 0 means at the origin, there is a formation of antinode. There is a formation of antinode. X equal to 0. It means at a displacement equal to 0, there is a formation of antinodes. Okay, then the next condition is that, look at here, the next condition is 2 pi x upon lambda is equal to pi. Okay, so this pi and this pi get cancelled and we can write this x is equal to lambda by 2. So, after the formation of this wave at x equal to 0, the next antinode will be formed at x equal to lambda by 2. We are going to again equate this 2 pi x upon lambda is equal to, what is next? Next is equal to 2 pi. So this 2 pi and 2 pi get cancelled, therefore we can write this x is equal to lambda. So next antinode will be formed at x is equal to lambda. So as we derive the relation between the distance between the two successive nodes is come to be lambda by 2, what happen in the case of antinodes? In the case of antinode, we can say that if we subtract this value x equal to 0 from x equal to lambda by 2, so we can get this lambda by 2 minus 0, which is equal to lambda by 2. Again we subtract lambda by 2 from lambda, that is this value from this value, it again comes to be lambda by 2. So we can say that the distance between two successive antinodes is also equal to lambda by 2. Like the distance between the two successive nodes is equal to lambda by 2, in the case of antinode, the distance between two successive antinodes is also lambda by 2. So we can say that by this equation we can say that this node and antinodes are alternately formed. Okay, if the antinode is formed at x equal to 0, then there will be a node and then again a antinode. Therefore, we can say that this node and antinodes are equally, or they are equally situated. Okay. No, so we calculate the distance between two successive node and two successive antinode. And what is the distance between the one node and one antinode? What is the distance between one node and one antinode? So we can calculate here. So we can summarize this like, where the nodes are formed, these nodes are formed at lambda by 4, 3 lambda by 4, 5 lambda by 4, like this. And where the antinodes are formed, the antinodes are formed at 0, lambda by 2, lambda, like this. So if there is a formation of node, antinode initially, there is a formation of antinode initially, then after 0 there must be a value lambda by 4. Okay, so here what? Here the formation of node, then we come to the lambda by 2 where the antinode is forming. After lambda by 2 we come across 3 lambda by 4, so it is equal to node. Then we come across lambda, so it is antinode, and this is node. In this way there is a formation of node and antinode alternately. If there is a formation of antinode first of all, then it's succeeded by the node. So what is the distance between one antinode and node? So we can minus this value from this value or this value from this value. So what we get? So we get, if we minus this lambda by 4 from 0, so it is equal to lambda by 4 minus 0, which is equal to lambda by 4. Okay, so lambda 4 minus 0 is equal to lambda by 4. It means the distance between two successive, or the distance between one antinode and one node is equal to always lambda by 4, but the distance between two successive antinode or two successive node, which is equal to lambda by 4. It must be remembered that the distance between one node and one antinode is equal to lambda by 4, and the distance between the two successive nodes or two successive antinodes, it is equal to lambda by 2. In this way, today we discuss all about the stationary wave. In the last lecture we discussed about the formation of stationary wave. We come to the point of the equation of the stationary wave. Today we discuss the conditions for node and antinode, the distance between node and antinode, and the distance between two successive node and two successive antinodes. In the next lecture we are going to discuss the very important properties of the stationary waves. So this is for today. Have a good day. Bye.